Plans for Euroluna. Presented in Toronto, April 29th, 2011 by Søren Rasmussen. Euroluna follows a design solution with one integrated spacecraft. It shall be a small rover which can also move on the surface of the moon. To get to the moon, we want to use an electrical propulsion system, the so-called VID. The electrical propulsion system needs a lot of power, and we will get the power from the solar panels. We want to do a minimum design of space components. That means we will use off-the-shelf components, and we are living on a shoestring budget. This autumn we will do the test of ROMIT-1. We have booked a flight in 310 kilometer polar orbit. The expected lifetime is about 6 weeks, and during these 6 weeks we want to test the communication function and the cameras. Further, we want to test the attitude control and our electrical propulsion system, the VID. ROMIT-1 has 9 solar panels, and we also have 6 cameras, where you can see 2 of them on this drawing. It will be one here in the interface between the 2 models, and the second will be here in the interface. There are further 2 cameras on the back side, and there will be 2 cameras pointing upwards and downwards. We have also in one of the modules an onboard computer and a radio, and the second module is the VID, the electrical propulsion system. We have booked a launch with Interorbital Systems, IOS. They have CubeSat launch adapters, and we need a special length. And the advantage of the CubeSat launch adapter is that we can fold the antennas inside the tube without any problems. After ROMIT-1, our ideas goes for ROMIT-2, also based on a CubeSat design. We want to go to a higher orbit so we have a longer lifetime. We want to install more solar power. We want to improve the communication system. And we also want to do an optimization of the VID module with respect to the power module. It would be very interesting to integrate the GPS system so that we know where we are, the position, and we want to do a radiation impact test when we go out further than 1,000 kilometer altitude. ROMIT-3 is the following of ROMIT-2, and there we want to go outside the GEO. Here we will have something to test with the communication. We will have something to test with the attitudes out there, because today we have magnetorque panels in the solar cells, and outside GEO it could be a problem to use the magnetic fields from the Earth. We want to go to a trajectory to the moon, which will come later on. It would be nice to orbiting the moon and find some retro rocket for landing on the moon, because we need the retro rocket because the electrical propulsion system is not having enough thrust to make a soft landing on the moon. And last but not least, we have to find a way to drive on the surface of the moon. We have looked into Smart 1 trajectory, and it looks as a useful way of going to the moon with our FEEB. You can look into internets on the HTTP address shown below. Thank you to ESA for these nice pictures. After this presentation, we had a nice discussion with Freddie from the university. We heard about the news from his launch providers, and he mentioned a possibility of a later GTO flight. So we are looking into getting into this one. We discussed the arrangement for the antennas in their X-Pod, their launch adapter, and that should also be possible. The solar power modules, it is advisable not to use foldable solar power modules because of the risk that they will not fold out. But for our power consumption, we will probably have to find a way how to get solar power modules folded into our CubeSat design. And at the end, we had a discussion if it would be interesting for our friends in Toronto to test our electrical propulsion system, and I'm sure we'll find a way to do that later on. This is all for this time. Søren Rasmussen did all the speaking and wish you a nice evening. Goodbye to everyone from Euroluna.